Welcome guys and girls to the 12-factor app discussion. This is a pretty popular system design interview topic. Now, if you go to 12factor.net, you will see these 12 factors listed with like a small tagline, which in my opinion is very confusing and overwhelming. My goal of this lecture is not to read through that website. You can do that by going there. My goal is to simplify it and make you understand why this is important, as well as prepare you for the interview. So we'll go through these factors, as well as we will discuss what kind of interview questions you expect out of this. All right, let's get started. In 2012, so this is quite some time back, developers at Heroku invented 12-factor app to help build web applications. This is a methodology used to make your application well architected. For example, it helps make your app scalable, portable, resilient, enables it to faster recover from disaster, minimize time and cost. Now, good news is if you know cloud DevOps best practices, or if you're using Kubernetes, you are already following most of this. So let's start at the number one factor. And again, everything in this is on Roman numeral. I guess that makes it more impressive. But if we take a look at a traditional DevOps flow, you, the almighty developer, used some IDE such as Visual Studio Code to create your application program, app.py, and you want to deploy this to a Kubernetes. So you also have a Docker file to containerize this app.py program. You check your application program and Docker file into a source code repository such as GitHub. And then the CI kicks off and builds your container image, saves it into, let's say, Docker Hub. And then CD kicks off and deploys your container image into a Kubernetes cluster running in Amazon EKS. Now, the first factor, Codebase, says one codebase tracked in revision control, many deploys. So Codebase is a single repository. This could be like a single repository in GitHub, or could be Subversion or any other Git repository system. So what does that mean? This means that one single repository is one single app, such as app 1. You can use this repository to deploy into different environments such as dev, stage, prod, but two applications must not share a single repository. What does that mean? Let's say there is another application, application 2. This must not be deployed from the same repository. So you can keep using GitHub, you just need to create another repo there. Now, what if there are common components between this app 1 and app 2? In that case, you should create common library and include them through dependency manager. So don't think too much about dependency, that's coming as the second. Another thing, the dev, stage, prod may not be same. All this is saying is the code, the actual application code needs to be the same, but there are other configuration, maybe the size of the database, or even the endpoint of the database will be different because you will deploy databases in 3 different environments. Those will be controlled outside of the code. And that brings me to the next few factors. So the objective of the next few factors are code can be deployed to any environment without any changes. How do you do that? So you remove any environment-specific dependencies from the code and you achieve maximum portability. So let's take a look at the second one, which helps you do that, which is dependencies, which says explicitly declare and isolate dependencies. So if we take a look at a sample code, let's say this is a Flask application. On the first line, it's saying from Flask import Flask. Now, if you run this program in multiple environments, it will always take whatever Flask version is installed in that environment. That is not ideal because in your dev, you might have one Flask version. In your staging, you may have a different version of Flask running. So as the tagline says, you need to explicitly declare the dependencies. So in this case, you need to create a file called requirements.txt and you define what version of Flask you want to use. And then in the Docker file, you need to do pip install requirements.txt. And when this code is containerized, it will specifically install Flask version 1.1.1. So that is the first part. How about isolate dependencies? So similarly, when you are running this program in your local, maybe you have some version 3 installed, you may be testing code for development, staging, production in your local. You want to ensure that those 3 different execution of code are in different isolated environments with the specific dependencies. So for dev, you should have a requirements.txt file with Flask version 1.1.1. Staging may have 2.1.1. And then you should use Python virtual environment for development, another Python virtual environment for staging. So virtual environment, think of it as a container environment where your program can run. You need to provide all the dependencies. Nothing is leaked from one virtual environment to another virtual environment. If you are using Visual Studio Code, if you open up a Python program, on the bottom right, you should see Create Environment button. And if you click that, it says VENV or Virtual Environment. Now, if you are using Kubernetes and you are using Kubernetes in local cluster and you are testing everything through container, this one is already taken care of. Now, following the same theme, if you have to make your code portable, you need to ensure that anything that's dependent on the environment needs to be taken out from the code. So let's say your code is connecting to a database, and this third factor is config. It says store config in the environment, and the code will look like this. You have to define the host endpoint, such as the URL of the database, the port, the database name, the user ID, password. So again, if you deploy the same code to staging, production, you need to change every time you deploy, right? Because the database endpoint, username, password will be different. Also, this makes the code vulnerable because if you accidentally push this code to a public GitHub repository, anyone can come and check the database user ID password. Even if you keep the repository private, anyone within your company can go and see the credentials of your database, which you may not want. So what do you need to do? You need to extract all those configurations outside of your code and store it in some configuration storage such as AWS Secrets Manager. So the code will look like this. It will fetch all the secrets from the Secrets Manager and then run the code. So the code becomes portable. You will just have different secrets for different environments, and when the code runs in dev or stage or prod, it will just fetch those appropriate secrets without changing any code, and it will run. As you could see, it's just grabbing the secrets and assigning them to the variables and then connecting using those values. Now the next one is kind of related to the previous two, which is backing services. Treat backing services as attached resources. So backing service is any service that the application consumes over the network as part of its normal operations. Examples could be data stores such as MySQL, CouchDB, messaging or queuing systems such as RabbitMQ, or in cloud could be SQS, etc. Again, for all those backing services, so database is an easy example, you have to make your app such a way that you don't need to change whether you're running your application in on-prem or in the cloud. So let's say you are using MySQL, and then you can still use AWS Secrets Manager, and you just get the URL, user ID, password from this config store or Secrets Manager in this case, and you will be just able to run. The same code should be able to connect to database hosted on-prem or cloud, or even your local environment. So the code for a 12-factor app makes no distinction between local, on-prem services, or even cloud services. To the application, all of these are attached resources accessed via a URL or other locator or credential stored in the config. If you want to swap out your local MySQL database with a managed one such as Amazon RDS, all you need to do is basically go to the Secrets Manager and change or add extra configuration for the cloud. Now, the next one is related to resilient as well as faster recovery from issues. So this one is called build, release, run, which says you should strictly separate build and run stages. I'm sure this sounds a little confusing, so let me make it a little clear. When you deploy your code, each time you change a code, you should put this through the CI/CD process. So you should not just go to production and change your code directly, because then there is no tracking in your repository. Every time you want to make a change, you should change the code, check it in to your repository, which creates a separate unique ID for that commit. That should go through the build process. That should create a unique build artifact and then should get deployed. Now, if we take a container example, because this is like the most popular technology right now, Kubernetes, there is another step which is kind of abstracted here. Every time a new code is checked in, the container image is created in the build with a new tag. Like, you should not use the tag latest, right? Then it will just overlap the older image. You should use a specific tag, and you need to use that tag to go and update deployment.yaml. So this is the config file in this case. So you check in a new code, a new container image got created with a new tag. The build phase goes to the deployment.yaml file, which is also in the repository, and then it updates the container image line with this new release tag, and that deployment file or config file is used in the deploy phase. So if you strictly use build, release, run for any changes, it allows you to revert back to any release in case of error. And also, it's easier to pre-produce or reproduce a specific release anywhere. So if, let's say, you want to create a new environment with a specific version of the application, not a problem, because you put everything to separate build and run stages. So run is basically deploy stages. So you know which version you want. You can specifically run it, point to the environment, and boom, the specific environment is up and running. Now, the next one, which is processes, allows you to make your application scalable. So the tagline is execute the app as one or more stateless processes. Think of process as the minimum deployment unit of your application. So one microservice backend code, for example, the container image we saw in the last diagram is one process. If you have multiple microservices working together for a functionality, there will be multiple processes. So processes should be stateless and share nothing, and any data that needs to persist should be stored in a stateful backing service like database. Containers are mortal, so containers go down, containers come up. If you create a stateful container where you are storing data in the container, when the container dies, your data goes away. So that makes your application very, very hard to restart. Also, it's harder to scale because if you're horizontally scaling your application, they don't have access to the data that's local to the other container. So any data that needs to persist should be stored in a stateful service like a database, which is external to the container. So even if your container goes down, the data still persists. Now, the next one is a little bit debatable. That's why I colored it in yellow. Sticky sessions are in violation of 12-factor application. Sticky session means that caching user session data in memory of the application's processes and expecting future requests from the same visitor to be routed in the same process. We are still early days of cloud migration. In some cases, in some legacy applications, they need server-side session state. For example, you are releasing a new product and you expect millions of visitors in the first 30 minutes, and you need the sticky session to be enabled to optimize the load balancing by reducing the overhead associated with session replication or centralizing session storage. So in those cases, you have no other options but to enable sticky sessions. This means the 12-factor app means creating a new application, but I kept it in yellow because this is not always possible. Now, the next factor is port binding. The tagline is execute services via port binding. So let's say you are running your Flask application, and Flask application is always exposed through port 5000, and you want to test it out. How will you test it out? You'll type localhost :5000, Now in actual running application, you should not be typing in the port, right? So that's what it means by execute services via port binding. So you introduce a service in between, and this service will give you a URL, and the user will type in the URL without any port number. And this service, by using port binding, will forward the traffic to appropriate port on the back end. So in this case, it will forward the traffic to port 5000 of the pod. So service handles this port binding. Another advantage is, since you are exposing it through service, another application can also call this URL without knowing which specific port to call. Now the next factor is concurrency. The tagline is scale out via process model. I don't know, by this time horizontal scaling was up and running. I don't know why they use this kind of fancy language, but let's simplify. Till now, the previous factors ensured that all the processes, remember process is the minimum deployment unit, could be a microservice backend, each application must come from a separate repository, are portable. So whatever we did till now made the codes portable. How? We moved the dependencies such as libraries, configuration, database location out of the code. We made the code stateless, and you might say, hey, how about logging? We are also going to move logging dependencies out of the code. So what that enabled us to do is you can scale the processes using horizontal scaling. Now this is 12 years back, so today horizontal scaling is the de facto scaling to go. So if you have watched my other videos on horizontal scaling, distributed computing, you are already covered. That's all it means by concurrency. Then the next one is disposability, which is to maximize robustness with fast startup and graceful shutdown. It says processes are disposable, meaning they can be started or stopped at a moment's notice. And some factors helped with this, because stateless processes are easier to restart because all the data is stored in database. Your process will receive a signal called sick term, which means that, hey, I'm going to kill your application in certain time. So if you can trap this signal in your application code, and then you could stop accepting new requests. You allow current requests to finish and then exit the application. But sometimes graceful shutdown is not possible. Maybe you got the sick term and then the kill signal is sick kill, but you got sick kill way faster than you expected because of some other unexpected reasons. Just return whatever you can stop whatever you are doing, and then just return the jobs to the queue. So let's say you are in between of processing some file, you can checkpoint it, save it to the database, or you are running some jobs, maybe you are using SQS, you can return those messages back to the queue, etc. Now the next one is dev prod parity, which is to keep development, staging, and production as similar as possible. So this was created before DevOps container was popular 12 years back. There was substantial gap between development and prod because time gap, there was longer time to go to production, there was personnel gap, there was separation between developer and operations, and tools gap, different tools used in dev and prod. Now, if you're using DevOps, you are implementing CI and CD, and time gap to go to prod reduced from weeks to basically hours. This basically says utilize DevOps practices. Utilize continuous deployment, use the same tools in dev and prod. If you are using containerizations, it already solves this because you are using the same libraries. Also, use the same backing service, as in if you are using, let's say, MySQL in dev, you should also use MySQL in production. You should not use, let's say, DynamoDB in production. And this all is kind of true these days if you're using cloud, because cloud services are cost efficient. You don't need to buy licenses. So let's say you are running Amazon Aurora. You can use that in dev, stage, prod. You don't need to worry about, man, I bought this Oracle license and it's based on usage. I don't want to use this in dev. But that's what this factor is. Dev and prod or any other environment should be as close as possible without any substantial gap. Okay, the 11th factor is logs. The tagline is treat logs as event streams. I said before that this is part of making the code portable, right? So let's say your code is running inside the pod, and then you need to send the logs to a logging backend. So one option is, in your application code app.py, you can code to send the logs directly to Splunk. So you'll have a Splunk URL or HEC URL with your HEC token. You define your log event and then do a API post to send it to the Splunk URL. But this will not be ideal because the code need to be changed between environment, dev, stage, prod, because you will have different logging endpoint. Code need to be changed for changing logging backend. So if you want to switch from Splunk to Elasticsearch, you need to go change this code drastically. Also, this makes the code tightly coupled with the log integration. So if your code is scaling up like crazy, the logging platform also need to scale up at the same rate. And this does not make the code portable. So what do? You move all the log forwarding capability from your code and utilize FluentD. So FluentD is a logging agent running as daemon set. It reads logs from std out and sends to logging backend. And even if you change the backend, all you need to do is change the configuration for FluentD. And again, FluentD can read a configuration from your config manager, and the config manager could be different in dev, stage, prod. And depending on the environment it is running, it will automatically fetch the correct configuration, send the logs. Even if you switch from Splunk to Elasticsearch or CloudWatch, it can handle all that. So on the right, the code is simply has business logic. You write, do a print event underscore JSON, and it's going to write it to std out. FluentD is going to read from std out and send it to the appropriate logging backend. Now, FluentD is the most popular log forwarding agent for Kubernetes. You got the idea. You basically need to separate this out from the code and use a log forwarding agent. And generally, these agents like FluentD also have some buffering and queuing functionality so that your code can scale up like crazy, and you can rate limit the way you are sending logs to the logging system so that the logging system like Splunk is not overwhelmed. Now the last one is admin processes. It says run admin or management tasks as one-off processes. At times, one-off admin processes needed to be run. For example, you need to go update some database values, or you need to run one-time scripts. According to 12-factor apps, the admin processes should run in the identical environment of the app, use same code base, and ship with the application. Pretty sure you folks are confused, so let me explain. What this means is, let's say you need to run a script. You just should not log into the production environment and just run the commands of the script. You should create a separate run, build, release. So you create the script, and then you create and you merge that into your code repository, which will create a separate build and release. And you should test it out using the same code base. So if a code base has a specific version of dependencies, libraries, you should be testing the script with the same dependencies. You should utilize the same dependency isolation that we talked about, and then in production, run it the similar way. Why is it recommending this way? So if this admin process does something bad, because you created a separate run, build, release, you can always revert back to the previous version. And the admin process should produce logs. All right, so now, hopefully these factors make more sense, and now you understand how they make your application more scalable, resilient, portable, faster recovery from disaster, etc. If you like this video and want to know more about other system designs, check out my best-selling course, Rocking System Design. Maximum discounted link in the description.